Hi class. So, one more example of a hypothesis test and confidence interval for two populations, and we're looking at two population means. Okay, so example. Suppose we wanted to see if there was a difference in the amount that men and women sleep. Say we sample 80 men and found the average sleep time to be 7.2 hours with a standard deviation of 1.3 hours. And we sampled 120 women and found that their average sleep time was 6.8 hours with a standard deviation of 1.2. Can we infer that there's a difference in the amount that men and women sleep? Okay, so step one, we developed a hypothesis. Now we always try to see what we're trying to infer, and we write that as HA. So is there a difference? So the mean of men is not equal to the mean of women. And then the null hypothesis is the opposite of that, so the equal. And we always just use the equal with the null to anchor our assumption. So we can calculate a p-value. All right. Step two is assign alpha, how willing we are to make a type 1 error, which is wrongly rejecting a true null hypothesis. We're going to assume the null and see if we have enough evidence against it. So we set that to 0.05. It doesn't say what it is in the problem, so 5% is the default. Now, did the sample results possibly allow us to infer HA? Step 3. And we have a sample mean for men of 7.2 and a sample mean of women of 6.8. They're not equal, so we could possibly infer it. How come we don't automatically infer it? Because sample results vary, and it's conceivable that the null is true, and we'd get this sample result. So we have to see how unlikely that sample result is. Step 4, what's our predictable distribution for the difference or between two sample means? And for means, we use a t-distribution because we don't know sigma. Okay, so the next steps is we calculate a p-value, and we'll do that via the calculator, and then we'll do a confidence interval. All right, so let's bring in the calculator, and we'll turn it on, and we'll say clear, and we go into stats, and we go to tests, so test, okay, and not a t-test because that's a one mean, but we're going to do a two-sample t-test, so we go down to 4. Right, say enter, and we're going to put in our summary data. So our statistics, our summary statistics. So the men were 7.2 with the standard deviation of 1.3 and 80. We sampled 80 men. Women were 6.8 standard deviation. So we can enter these. I already entered them, and the number was 120. Now we want the not equals, so we'll hit that enter, and we'll come down. We'll just use pooled no. And then we hit calculate and we get our values. Okay, so our t-stat is basically 2.2, which is like a z-score, pretty far out there. So 2.2, and our p-value is 0.0294, so 0.0294. All right, so now, we'll remove the calculator. So now, these sample results are pretty unlikely, only about a 3% chance of getting those sample results if the null hypothesis was true, that they're both equal. Now that's pretty unlikely, less than our willingness to make a type 1 error, which is 0.05. So we'll reject HO. Since the p-value is less than alpha, reject HO. There is sufficient statistical evidence to infer that there is a difference in the amount that men and women sleep with this sample data. Okay, cool. Well, what's our 95% confidence interval? Well, 95% confidence interval for what? We have to look at the difference between two means. The mean of the men minus the mean of the women. The population mean of the men minus the mean of the women. So we're going to get a 95% confidence interval for that. So let me show you how to do that. Let's bring the calculator back in. And it's real simple. We go to stats. There's all formulas for that in the book, but we're using this. Go to tests again. And we go to not a z interval, not a t interval, but a two-sample t interval. Hit enter. We put on our stats, again 7.2, 1.3, and 80 for the men, and 6.8, 1.2, and 120 for the women. And we go down, 95% confidence level, pooled, no, and we say calculate and enter. And here's our confidence interval. It's coming up. Okay. Between 0.04 and 0.76. So we'll write that in there. So it's between 0.04 and 0.76. Okay. So we are 95% confident, which means 95 times out of 100 on average in creating these intervals, that this interval will contain the true population difference between the men and the women, mean average sleep times. So that does mean that the difference, we think 95% level, that there is a difference of more than, 0.04 hours. Not much, but almost up to 3/4 of an hour. So, but we would say that it is in fact that they're not equal because 0 is not in this interval, so therefore they're not equal. So that concurs with the hypothesis test. All right, well that's a hypothesis test and a confidence interval for two population means. Hope that's helpful.